Hello guys, welcome to today's stream. Um, welcome to today's streams. I know, like I've not been streaming for a while. Maybe not a while though, but for 1 week. Yeah, and it feels like forever. But I'm back. I'm back. I'm back. I'm back. I am back. Yeah. So last time we were talking about we were solving this competition. This your voice, your device. Kiswahili ASR. Yeah. And since our last stream, we were unable to break this score, so we decided to like train Whisper from scratch. Yeah. And it turns out people are getting really impressive scores: 0.23, 0.23, 0.23, 0.29. Yeah. 0.35. I never continued. I only like created the notebook. I never continued further because I got bored because I was not breaking like 0.4. So like I took a break from this. Yeah. Only thing I would like to add here is predict with generates. So there was this bug we were facing of like validation running for like few like steps, that it breaks because of out of memory issues. But then when you do predictive generate is equals to true, it solves the issue. I don't know why, but I saw it in a GitHub issue, so I tried it and it worked. It worked. Yeah, so this is what it does. Let's search for it. Predict it generates. Yes. For sequence-to-sequence tasks such as translation or summarization, for such generative tasks, usually metrics such as ROG or BLEU are evaluated. However, these metrics require that we generate some text with a model rather than a single forward pass, as with a classification. So it allows the sec-to-sec, sequential-to-sequential trainer, allows for the use of the generate method when setting predict with generate is equals to true, which will generate text for each sample in the evaluation set. That means we evaluate generated text within the compute metric function. We just need to decode the predictions and labels first. Yeah. Yeah. And this, adding this, it solves the issue. You see, we had even commented the validation parts. Now we can uncomment it, and also eval steps. Okay, this is okay. Eval strategy, instead of no, you can set it to steps, or epoch. So epoch takes a long time to run, so I just set it to steps. Yeah, and then I define the number of steps you want to log your metrics in the configuration. For me, it's 4,843. So I wanted to divide it by 3 because evaluation as well takes a lot of time. It may take 1 hour to evaluate the whole validation set. Yeah, so you can say I divided it by 3, so you have 3 steps, and then the metric. Okay, this training loss is like useless at this point. You just need to use this to do the metric calculation. The where that is what you have been evaluated with. So currently I'm bored. with this project. I mean, like, there's no way I'm going to like run this the whole night, and then when I submit, I can't even break 40. I don't know what the people who are breaking 40 are doing, to be honest. You can see, like, I really struggle, yeah. Yeah, so I took a break. You see, like 8 days ago, then I took a break. Yeah, and that is what. And to be honest, I feel like this is the last stream. The previous stream was the last stream for this because it's we already looked at the pipelines for like training the models. So yeah, I feel like that was the last stream. So today we are going to another interesting project that interests me. This bored me, to be honest. But maybe I'll be back. Still 18 days to go. So I went ahead and did the microbiome classification challenge since it's 11 days remaining. Yeah, yeah. Currently, it's still struggling to break to this like this cause. I hope this is not post processing. But these two are definitely post processing, and they will be removed. So don't be discouraged. Yeah, don't be discouraged. Even if you look at the discussion, we had talked about this. I don't know, but you cannot tame people's curiosity. To be honest, I also had gotten this call. You can see, but then I asked the admins to remove this sub from my sub because it was like it was unfair. Even I am Dente, credits to him. Wanted to delete his. You also had this call, and yeah. So I feel like the first person is. I feel like even machine learning is like using post processing, to be honest. Yeah, but I don't know. I don't know. He might be using post processing, but I don't know. The people who I'm sure they are not using post processing, like illegal post processing, is Momati. So I feel like this is the number one currently with 0.00008, and this is the score to beat. Yeah, currently I've hit a roadblock. I cannot like break. At least I know me and Pegasi are doing the exact same thing. But break into this cause require. I don't know, to be honest. I don't know what they are using. I'm not sure. And you can see this cause they got it like 2 months ago. Um, 2 months ago, at least 14 days ago is a bit encouraging. Yeah, but the problem with this competition, it requires a lot of compute, to be honest. I feel like most people in this competition will be disadvantaged with the amount of compute they have. It takes a while. Like my feature engineering process was taking almost 3 days, but then I found out it was a skill issue, and now it's I did some like multi-processing refactoring, and now it can run overnight. So like 8 hours of when I sleep. When I wake up, it either has finished the training, which engineering, and I need to like wait for another like 2 hours for test. Yeah. In essence, like 15 hours. So still, and I'm using a PC. I'm using a local PC. So I wonder what people on Kaggle are using, like with a 12-hour limit. So yeah, but maybe there's an easy way to compute the feature engineering. Maybe it's a skill issue. Yeah, maybe it's a skill issue. Yeah, so I cannot stream this, to be honest. It takes a long time, man. So the only one left that is interesting to me is Barbados. Yeah, so Barbados. So currently, Barbados, the score to beat is 0.96. Me and my teammate are at 0.86. Still a long way to go. And yeah, so for this project, this is what I'm going to stream today. Yeah, and maybe subsequent days I'll continue from this, but I'll only handle the OCR part because the polygon part. Okay, let's read the information. In Barbados, all survey plans must be submitted in analog form, blah blah blah. Your challenge. Build a solution that can automatically detect and extract land plot shapes from scanned survey plans and convert them into standard digital formats like shapefiles. On top of that, you'll also need to pull out important metadata like the lot number, parcel area, surveyor name using OCR or other machine learning techniques. The extracted digital data will then be in a format that can easily be entered into a digital registry. So this is a pilot challenge focused on just one district in Barbados, but the winning models will be put into practice for the whole country. Your models will help modernize how land records are handled, saving time and money, reducing errors, and unlocking new social and economic benefits for all on the island. Yeah. So for this project, there are two tasks. One is OCR, the other one is object detection, or or segmentation. However you like do the, however you do the, but it's segmentation because you have to provide mask coordinates. Yeah. And so for me, I'll only handle the OCR parts. To be honest, my teammate is handling the polygons parts. Like I'm still struggling to understand the polygon parts. Yeah, we asked a lot of discussions, and they are very helpful discussions. Thanks to Joseph Gitau and Mohammed Tuo for like the informative discussions and for their generous like replies. Yeah, and also Mohammed Abdel Razik. I hope I've pronounced your name right. For like provoking these discussions. Yeah, we are all stupid, but you're not stupid. Like the understanding part is a bit tough for us in this competition. Not you're not alone. I'm also struggling. A lot of people are also struggling. So yeah, yeah. So you're not the only stupid guy. You're not the only stupid guy, to be honest. So you can go through these discussions. But like for me, I was wondering how are we supposed to like, I mean, perform evaluation if the masks do not align well in the images. Like this was my question. But then Mohammed too thanks. The polygon to mask function works as if the parcel region of interest was cropped out of the original image. Hence, it's impossible to overlay it on top of the original full image. So that's why. So, and then I asked, how then are we calculating the IOU from imperfect overlays? So like I replied, the polygon to mask function is what makes it possible because it doesn't take the full image as reference but only focuses on the parcel of detection ROI. ROI means region of interest. So basically they've normalized you normalize the masks, then you do evaluation. Yeah. So this is what you're going to handle today. If you don't have the data, I would advise you to download the data. It's pretty huge. I don't know if there's someone in the chat. Mohammed, where is Mohammed when we need it the most? Mohammed, where are you when you need it the most, man? Yeah, I think he's not participating in this competition, but Mohammed, shout out to Mohammed. He's such a kind guy. He like uploads the data to Hugging. I mean, not Hugging, but Kaggle for us to use. Yeah, so you'll just have to download the data. And today we are shifting. We have been using Google Colab for a while. Today we are shifting to Kaggle. At least you will see how you can also use Kaggle to run in your experiments. So first thing about Kaggle, you have to sign up, register your account, then you have to verify yourself. When you verify yourself, that's when you get access to the GPUs. I'm not going to go through that whole process, but you can do that for yourself. Yeah. So today we are doing. I mean, we are going to run the experiments on Kaggle. Yes, we are going to run the experiments on Kaggle. Yeah. So the settings part, you have to verify yourself. You have to font verification, exactly. You have to do font verification to get access to the GPUs. Sorry. So when you look at here, you'll get that you're given 30 hours of like GPU compute. At the moment, I'm only left with 11. Yeah, I'm only left with 11. So I'll shift. I'll shift to another account. Yeah, I'll shift to another account. Sign in with Google. I'll use my other account. Nice. So I have this account as well. It's also verified. Um, yeah, it's also verified, and I have. You can see like you're given 30 hours. Yeah, you're given 30 hours of GPU compute, and yeah, this is much better than Colab. Since Colab, you're on like yes, you're given GPUs, but you don't know when the session will terminate if you're not on Google Colab Pro. At least on Google Colab Pro, you know it will terminate when the credits end. But if you're in free tier, then you don't know. Yeah. So let's see if we'll get the Barbados dataset. Okay, I have to share it. I have to share it. Um, yeah, I have to share it. Yeah, I have to share it to this account. So I'll sign out again and then sign in with the previous one. Uh, and then share the data sets. Yeah, so I have this data set. It has the survey plans. I'm going to share it with myself. I don't know if I can set it public for everyone to use, but yeah, you can just upload it for yourself so that you learn the process at least. But if you want to share with other people, like you can just share here. So I'll share it. Yeah, save. And then I sign out.
He decided that he wasn't gonna eat Steve because we're all kind of like Steve one way or another. Unfortunately, Steve killed the young boy, the young man, and I've been swimming in the sea ever since.
Yeah. Sometimes I hold these like live sessions, and then I just get disappointed because not like people are not joining. So I just ask myself, why am I doing this? Like last week, I was fighting with my thoughts. Why am I doing this if people are not joining? Like I'm trying to share the knowledge that I have, and maybe people are getting bored that they don't want just to like come to the live streams. So I just like I lose interest, and then I just say, let me do my own things. Like for example, last week I took a break because yeah, I was bored, and I was able to accomplish a lot of things actually. I joined the MPEG competition, uh, joined the Barbados competition as well. Yeah, but then when I go and look at my like when I upload the videos to YouTube, and I see like people like are actually viewing the videos, I get like a bit of motivation. Yeah, but I'm grateful for everyone who supports me. You're the reason I keep on going. You're the reason I show up to these streams, and yeah, I'm just grateful, and I hope you remain like you remain a loyal viewer. Yeah, and I hope you gain like important. I hope you get um, important what? Important nuggets from the stream, man. Yeah. So Barbados, not automation. Okay, the data set has not appeared yet. It should appear with like shared. All these are collaborations. or maybe I need to like log into my Gmail and accept it. I'm not going to show this part here. Yeah, I'll do it offline. Or maybe I can do it. Like, what's the harm? What's the harm, guys? What's the harm? Nice. Now we can access the datasets. So, how you like create a notebook based on this dataset? You just come here, code, and then create a notebook. Then when you create a notebook, this dataset will be linked to your notebook. So you can access it as if you're accessing a local folder. Yeah, so as you can see, the dataset has been linked here. Yeah, and you can access every file and directory. Yeah, and you're going to rename this. So Barbados. Since you're only dealing with OCR, I'm just gonna name it like that. I'm gonna delete all this. Yeah. Now I want us to look at one of the images, and I want to explain it to you guys exactly what's the task ahead of us. Yeah. So if you look at the sample submission, let's look at the sample submission first. Let's look at the sample submission first. So you have a target survey. A target survey. If you look at where is that? Oh yeah, how to prepare a submission. So the target survey is a concatenation of the OCR text for these fields. So land surveyor, surveyed for, and address. So let's look for those information in that image, the image I just showed you earlier. Yeah. So you have this image. I don't know if you guys can see, or I need to download it, but I need to add another window on my stream. So like I'll just try to show it here. Yeah. So the land surveyor. The land surveyor is here. As you can see, Michael H. Hutchinson. That's the land surveyor. This is the OCR text that's supposed to predict. And then surveyed for, you can see surveyed for Mila Sophia. So we need to extract this information. Address, where's the address? Where is the address? Wait. To be honest, I don't know where the, oh, address. Yeah, this is the, let's see. Just have to like, come on. Yeah, so you can see the address is like the lot number. I bet, yes, the lot number. I don't know if you guys can see. Yes, the lot number. So that is what you're supposed to like extract, and the lot number is here, as you can see, lot 179, Zagari Avenue, etc. You also need to extract the certified date and like the reference number, something like that, or the area as well, the total area. So for example, for this 929.3, can you guys see? Okay, yeah. So for this 929.3, 929.3. You see the address. Thank you for joining my brother's email. Man, I was here alone. I was about to quit. Like, I was so disappointed that I'm here alone. People don't want to join. I don't know. Yeah. But I hope they will see the recording though. Yeah, so this is the area we are supposed to predict the total area, 929.3 square meters. Then the polygon part, the segmentation part, we are supposed to extract the binary coordinates for this polygon coordinates for this. You see this green part here? Yes, that's the land we are supposed to like. We are supposed to extract the coordinates for. Yeah, yeah. So that's the task ahead. And as I've said, I think I will only handle the OCR parts until I understand the polygon parts. Yeah, but that I'm not like promising you guys. The only part I'm promising you guys is the OCR part. Yes, the OCR parts. Yeah. So, okay. So there are many ways to like do this. Yeah. The first thing you can do OCR. You can do OCR, extract the text. For example, OCR that does line by line. So you'll have plan of land, get the text, get the text, surveyed for. Then you have like this whole text for this image. Then once you get this text for this image, you can use a large language model. You can use a large language model to answer the question. So you can say I have this extracted OCR text from an image. I want to extract the surveyed for. I want to extract the land surveyor, the address, the area, the total area, etc. That's the first thing you can do. Second, if you've ever heard of vision-language models, this is the second way and the most easiest actually, because the first step you need to do two steps. You first need to OCR, then use a large language model to generate the answers. But for the vision language model, it does the OCR for you. It actually does not do, like, okay, I don't know if doing OCR is the correct term, but it can see the image. So it just generates the predictions using just one step. Yes. So that is what we are going to do on the stream. We are going to use a vision language model. So for the people who are new to large language models, I feel like this is the most interesting thing. This is the most interesting stream for you guys now, and I wish you like join the stream. I mean, watch the replay maybe. Yes. So do you guys know what a vision language model is? So we are going to start there. What is a vision language? Do you guys know what a large language model is? What is a vision language model? Let's start there. Yes, so a vision language model are multimodal AI systems that integrates computer vision and natural language processing to process and understand both visual and textual data. This model can take inputs such as images or videos alongside text and generate outputs like captions, answers to visual questions, or object annotations. Yes, so a vision language model combines computer vision and NLP. Just like I said, you can see the image and generates the answer. Sorry, I need to reply to something here real quick. Yes. So it combines computer vision and NLP. And what are some examples of this vision language model? So, vision language leaderboard. Every time, just go and search for the leaderboards, man. Yes. So we have an open vision language. Oh, before even we go, okay, let's look at the vision language models. So there are very many vision language models, to be honest. And you can see them here. This is for open vision language models. And you can filter. So in like the LLM world, in the generative AI space, one thing you have to pay attention is the compute, because you cannot run like a huge model on like limited compute. That's why you hear like those memes of GPU poor. We're all GPU poor. So for example, on Kaggle, we only have GPU P100 and GPU T4. All these are either 16 GB VRAM or 16 GB VRAM or 15 GB VRAM for the P100. Although I have seen like others can access the 4L4 GPUs. I don't know how people are getting the 4L4 GPUs, but I feel like it's for a specific competition. So for example, us, we only have access to 2 T4s and a P100. Ignore the TPU for now. So we have a P100 and 2 T4s. At the moment, we only need the P100. We can use the 2x T4 to run bigger models, but for now I'm going to run a very small model for like latency while we're streaming, so that you can see like the results as quick as possible. But you can try the 2x T4. So for now we're going to use the P100, and we're going to use this to study the amount of compute we actually need. Yes, and we're going to start the session. Start session. Yes, as we wait, let's go back to the OpenVLM leaderboard. So you can see here we have a filter for the model sizes. So one rule of thumb you have to know, you have had like you have to estimate, you have to know the model parameter size in billion. So for example, you have had 7 billion parameter model, 72 billion parameter model, 4 billion parameter model, 1 billion parameter model. And when you hear this billion parameter model, to estimate the amount of compute you need for the model alone, you just multiply the digits in front of the billion times 2. This will enable you to know the amount of compute you need for FP16, floating precision 16 models. We talked about floating precision in our previous streams, so I'm not going to like explain that again, but yes, that's how you determine the amount of compute. So you have a billion parameter model, for example, a 7 billion parameter model, multiply it by 2, and then you get 14. So for you to run a 7 billion parameter model in FP16, you divide it by, you multiply it by 2. So for a 7 billion parameter model, you need 14 GB of VRAM. 14 GB of VRAM, yes. But now there's other things called quantization. So quantization enables us to run the models in like fewer compute or fewer memory. So yes, so let's read about what quantization is. So LLMs such as GPT have transformed NLP with GPT-3, etc. Technologies like quantization and distillation have been developed to shrink model sizes. Quantization in particular is a key technique for enhancing efficiency without greatly compromising performance. In this article, I explore what quantization is. Yes, so I can link this article for you guys to read later. I'm going to link it in the chat. So quantization is a technique used in machine learning to optimize neural network models by reducing the precision of their parameters. Exactly. That's why you hear me talking about floating precision 16, FP32, etc. So this involves converting parameters from high precision formats like 32-bit floating point, which is FP32, to lower precision formats such as 8-bit integers, int8, but the most common one is int4. So we convert FP32, FP16 to int precision, like int8, int4. Yes, The primary objectives of quantization are to lower the model's demand for computation and memory, and to improve inference speed and efficiency. Although for like NVIDIA GPUs, quantization, like I came to realize based on the experiments I used to do in my previous company, that quantization actually hurts the inference speed, because the NVIDIA GPUs have been optimized to run on floating precision, like yeah, on FP16 to be honest. Yes. So the speed, I don't know. I'm not really sure, but efficiency and memory are definitely. So why quantization is important? Efficiency. Quantization reduces the amount of memory required to store the model weights, making it feasible to run large models on devices with limited resources. Speed. Quantization enables lower precision computations to be performed faster. Okay, maybe in CPUs, but not in GPUs to be honest. Yes, NVIDIA GPUs are optimized for FP16. And like for example, H100s now are optimized for FP8s. Yeah. Cost, yeah, obviously reduces cost because you can run like smaller models on consumer GPUs. And it talks about the data types used in AI and machine learning. Actually, this is a really good blog. Yes, so you can read it intensively later. So float 32-bit floating point format includes 8 bits for the exponent, 8 bits for the exponent, 23 bits for the mantissa, and 1 bit for the sign. It provides high precision but has a significant computational and memory footprint. True. FP16, this format now it reduces the 8 bits to 5 bits and 23 bits to 10 bits for the mantissa, and then use 1 bit for the sign. So it has 5 bits for the exponent and 10 bits for the mantissa, resulting in a narrower range compared to FP32. That's why in our previous projects we had to like use FP16 here to have the precision of the model to reduce memory. Yes, and now this explains it so well. Oh, we have even bfloat16. So bfloat16, so we have, oh, this is FP16 and we have bfloat16. Actually, you can actually change here. I feel like it has bfloat16 as well. BF16. Yes, I feel it has. Maybe that's an assignment for you guys. So bfloat16 uses 8 bits for the exponent and 7 bits for the mantissa. So offering a broader range than FP16 and reducing underflow and overflow risks. Despite having fewer significant bits and slight lower precision, BF16 generally does not significantly impact model performance. True. So in machine learning, FP32 is referred to as full precision, while BF16 and FP16 are known as half precision. So this offers a broader range than FP16, so definitely much better than FP16. The int8 data type uses 8-bit representation, allowing for 256 different values. So now if a 7 billion parameter model requires 14 GB of VRAM, what about in int8? It requires 14 GB of VRAM in FP16. What about int8? Remember, in int8 we have halved the precision again to the same way. Okay, let's start here. How much memory will a 7 billion parameter model take if it's running in FP32? That you multiply by 4. So 7 times 4, it's 28. But if it's running FP16, you divide that by 2. So it's 28 divided by 2, 14. If you're running it in int8 precision, you further divided by 2. So 7 billion parameter will use exactly 7 billion, no, I mean 7 gigabytes of VRAM. Yes. And I feel like, okay, we get there. So for example here, so 500 million params multiplied by 4, for int8 multiplied by 1, for FP16 multiplied by 2, for int4 multiplied by 0.5. I hope that clears your computes questions. Yes, so you can further read this blog post. Yes, you can further read. Actually, this is so informative. I have to like take my time to read it again. Yes. Now we are going to, so where do we get this model? The next question, where do we get these models? So to run these models locally, for the GPU pool, we have Olama. We have Olama, this is for the normies. And then we have Llama CPP, this is for the techies now. People who, yes, for the techies. But Olama is easy to use, easy to like get into. Oh, we also have LM Studio. LM Studio as well is also a good option for running local models. But today I'm going to use Olama since this is what I'm used to. I'm a normie. I'm a normie. So we have Olama, we have LM Studio. LM Studio. Yes, discover run on local LLMs. And we have Llama CPP. Yes. You see, even you're taken directly to GitHub. This is for the devs, man. For the devs, for the tech savvy. And then, if you want to deploy these open source models, we have VLLM. This is my favorite, actually. This is my favorite. VLLM to run open source models in production, and we have SGLang. SGLang. This is also a very good one. XAI uses SGLang while OpenAI uses VLLM. So these are the two options to run the models. So my brother is asking if Llama is free. Obviously, Llama is free. So I'm going to show you Olama. So Olama here, if you have macOS, Linux, Windows, like currently I have Windows. So if I wanted to like download for Windows, you download the executable. For Linux, you have this curl function, a curl script, and also since you are running it on Kaggle, we are going to use this curl script. Yeah. So for the macOS people, you can download for macOS. So for the models, my brother is asking if Llama is free. Yes, you can access Llama here. You can access a lot of Llamas. So you have 3.1, 3.2, 3.2, 3.3, 3.2 Vision. Yes. And based on our talk, we have seen that we need vision models. We need vision models. So we go back to our vision leaderboard and then filter for 4 billion parameters because we are we are GPU poor, man. We are GPU poor. But on Kaggle, you can models on Olama are quantized to like int 8, I bet. So a 7 billion parameter model will run using 7 GB of VRAM. So you can check this as well, 4 billion to 10 billion. But for this stream, I'll use less than 4 billion. Or actually not less, 4 billion and above. Yes. So you have a vision, you have this leaderboard. Even method, vision model. Yeah. You have even Gemini here. You can't use Gemini, it's not open source. So you have 2.57 billion parameter. This is actually so good. We might even decide to use that actually. But yes, we are going to try the 2.53 billion parameter model. 2.53 billion parameter model. So we go back to Olama and search for 2.5. Yes, here. No. This is the vision language model have the extension VL. So you can come here and you see all the available parameters. So you have 2.53 billion parameter, 7 billion by default is 7 billion. You have 32 billion, 72 billion, but this we are GPU poor, so we cannot even use the 32 billion and 72 billion, but we can definitely use 7 billion and 3 billion. But for this, I'm going to use the 0.2.53 billion. Great. Now we have talked a lot. Let's go to coding right now. Let's go to the fun part of coding. Yeah. Yeah. So we need to install some things. Like the Kaggle kernel is Linux based, so we are going to use the curl function for the Linux, like, yes, for the Linux OS. We need to update the environment and install PCI utils, and now we are going to go back to Olama and okay, let's copy this first. We already know the model they're going to use, so paste it here, and then we go to the installation parts. Yes, copy that. Yeah, and we are good to go. So we install all this. Nice. Do you guys love the whites, or I should like change it to dark? Where's the dark one? I've forgotten to like. Okay, I can't see it. Yeah, I bet you're stuck with this. Lepolian, my brother. Welcome to the stream, guys. Bro, welcome to the stream. Nice, now we have installed. System D is not running. NVIDIA GPU installed. Olama API is now available. Nice, now we can. It obviously counts. It obviously counts, bro. But I'm going to. Oh. I have not found where to change it. Yeah, so you're stuck with these whites. Nice. Now we have installed. Okay, we have installed Olama. Now we can run Olama. It's now available at this endpoint. So the next thing we are going to do is now download the model. So how to download the model? You just say Olama pool, then the name of the model. So remember we had our name here. Where did it go? Yes, we had our name. Sadly, we have lost it. But let's go and search for it again. Quen.2.5 VL. We need a vision language model. We copy it here. Yes, and then we pull it. Olama pull. Olama server not responding. Could not connect to Olama server. Yes, obviously we need to do some things. So we need to do threading and serve the Olama as a background process. So we need a sub process as well. Time. So define run Olama sub. Yes, and we run this as a background process. Olama sub. Yes, get the thread. Dividing the thread targets the function. And then we start the thread, and then we sleep for a while, 5 seconds or 10. Run Olama serve. Okay. Could not find. Generating new private key. Okay. Hopefully now it runs. Nice! We are downloading. And it's pretty fast. It doesn't depend on your internet, to be honest. Yes, because it's running on a cloud somewhere. Nice! Now we have our model. Man. Now we have our model. Okay, it's very verbose. I don't know how to run it in verbose 0 mode. Nice! Success! So the next logical thing is to test the model. I'm so excited, man. I'm so excited. Are you guys excited as me? And now we have the images, yeah? So we're going to pick one image, test image path. All this actually is the same thing we were doing on Colab. Like copying the path, you just come here, select this like double slice or something. Yeah, and copy the path. Nice. So we have a test image path. So we are going to test, okay, so we have a test image path. We're going to import image from Peel. From Peel, import image, and then we're going to open this. Yeah, obviously, Cyril, you're excited, man. Image test. Now we're going to test this live to see this image. Nice, and we have our image now. We have our image. So remember the goal. Actually, let's load one of the train sets. I import pandas as PD. Load the train sets. Train is equals to PD dot train CSV. And then we load the training set. Copy the paths. It's very simple. And yeah, paste it here, and then display it. So we're going to display the train.head, and you're going to see the columns we have. Nice. So the columns we are interested in this stream are the OCR columns. We're not interested in this geometry column right here. We're not interested at all with this geometry column. This is for so this geometry is what you're going to create mask for, this land. So we are not interested in the mask parts, we're only interested in the OCR part. So we see the columns that we need. So we need the land surveyor, we need the surveyed for, we need certified dates, we need the total area, we need the unit of measurements, and we need the address as well. And we need the parish as well. Parish is this St. Philip right here. You see this St. something? That's the parish. St. Philip. You can see St. Philip, St. Philip, St. Philip, St. Philip. Address is this at right here. So lot 179, etc, etc. Unit of measurement is these square meters. And remember, for you to, so since the evaluation metric is ordered a rate and accuracy, you need to like exactly in your submission to exactly submit it as this. But in the image, you can see the square meters has some full stops. So you need to post-process the answers later. Yeah. Total area is this right here. Total, you can see total 929.3. Certified dates. Actually, instead of like just picking a random image, let's pick one that is in the training set, so that we have actual ground results for testing. Yeah, so we use this new ID that is in the transfer. Nice. So we want to actually, we don't, okay, the display parts, you have already seen the display parts, but you want to print the first row. So for IDX row in train.iteros print row. So we need the land surveyor we need the surveyed for, we need, okay, I'm just going to copy and paste all these. Nice. And then we are going to break at the first index because that is what we are actually interested in. Break. Yeah. So land surveyor, we need the surveyed for. Copy this. Or it's easier to type, bro. Nah, it's easier to paste. Surveyed for, we need the surveyed for, we need the certified dates. We need the total area. We need the unit of measurements. And we need the address. What else? We need, yeah, two remaining. We need the parish. Yeah, we need the parish. And we need the Altinum. Let's go now. Yeah, the fun part now. Nice. So you have land surveyor Jennifer Alain. Okay, maybe you need to add some things here for easy identification. Nice. I feel like that's better. Great. So you have land surveyor Jennifer Alain. Yes, and you can see Jennifer Alain. Surveyed for, we have Rico R. Wilshire. Surveyed for Rico R. Wiltshire. Certified dates 2020. Okay, also see the date is formatted as well. 2020-09-17. Yes. Then you have the total area 596. You can see the total area is 596. Unit of measurement square meters. You can see the unit of measurement is actually square meters. um, address lot 468, address lot 468, Ruby development, etc. Parish, St. Philip. Um, so that St. Philip, where is it? It will not, okay, not only will it appear the address, sometimes it might not appear in the address, but this somewhere else it appears. Let me try to see. Let me try to see. There's actually somewhere it appears. Hmm. There's somewhere. I Ginger Drive, Jasmine Avenue, Ali Simmons, Whiten. Okay, I don't know where, but it's definitely here somewhere. It's definitely here somewhere. I just can't see it. Can you guys on the stream see it? Can you see St. Philip anywhere? Yeah, if you as a human are struggling to find St. Philip, even the AI will struggle. So this is a good test for us to see if the AI will struggle. If the AI will struggle actually. Yeah. Nice. LT number, it's this val reference. So you have 7703090068, 7703090068, and you can actually see it's formatted using dots. It's formatted using dots. Yes. So now, in simple terms, in the most simplest terms, the goal is given such an image with this information in the image. Can your model predict all these values? Can your model predict all these values? Yeah. So what you're going to do is prompt engineering. We're going to do prompt engineering. I know a lot of you guys have heard about prompt engineering. If you've never heard about it, just go and research what prompt engineering is. But it's basically creating a prompt to guide an LLM to do the task you need it to do. So in our case, we need an LLM that will predict all these values. So for me, I'm not going to struggle. I'm just going to check this. Copy this. Go to Google AI Studio. Go to Google AI Studio. I need to sign in to Google AI Studio. Okay. Yes. So I'm going to ask Google AI Studio to create the prompt for me. I'm going to ask it to create the prompt for me. Yeah. So I'm going to say I have an image with information that I need to extract. These are the informations I need. These are the information I need. This is the information. Oh, these are the values I need to be extracted. OCR the something. And it also shows the example values. For example, the date should be in the same format as seen in the example value. We also saw the square meters. So the square meters in the image might appear as square. Get rid of the full stops. Also, else LT number should be separated by dots or full stop. Since in the images it might be separated by slashes or even hyphens. By slashes or even hyphens. Please kindly generate for me prompts to accomplish this task. Do you guys use AI in your work? Obviously, everyone uses AI. If you are not using AI, you're missing out. Nice. Now we have a good prompt. We have a good prompt, guys. We have a good prompt. Extract the following information from the image for each field. Follow the specified formatting rules. Land surveyor. Yes, I'm using please, man. I'm using please. So that when the AI gains consciousness, it knows I was kind to it and it doesn't harm me. Do you believe in AIs becoming conscious? Do you believe in AI becoming conscious, Simel? Nice, and you have a good prompt right here. So I'm gonna copy this prompt, copy as text, and then we go back to coding. We had missed coding. Nice. So what we wanna do is test if the Llama 3. Not Llama, the Quen 2.53 billion parameter model can be able to answer this question. Nice. So we import our Llama, obviously, and we create our prompts. Then we paste what Gemini has done for us. Pretty decent job. You want to extract information from my image? Standards? No. Oh, okay. We need it from here. Extract the following information from the image. For each field, follow the specified formatting rules. Land surveyor, extract the full name of the land surveyor. Surveyed for, extract the full name of the person or entity from the survey was conducted. Certified date, extract the date in that format. Total area, extract the numerical value for the total area. Unit of measurement, extract the unit of measurement if it appears as square meters. Remove that's some processing. LT number, extract the LT number, ensure that the components of the number are separated by full stop. Nice. Now to the fun parts. Now we ask our AI to generate for us the answer. Who wants to bet on the chat if this will work? Will it get everything correctly? I'm betting it'll get the parish wrong. Because even I as a human am struggling to get a parish. Similar, what do you bet? What do you bet, bro? So Olama chat. So this is how we call Olama with a specified model. Specify the model that we are using, which is Quen 2.53 billion parameter model, the one we downloaded. Obviously, make sure you had downloaded the model. Then messages. We pass in the messages we want to be processed. So we have two roles. First, it's the system role. Actually, three roles: system, assistant, and user. Here, this is like, to be honest, content. I'm just gonna reuse the most common system prompts, which is you are a helpful assistant. Oh wait, are you guys seeing this? Sorry. You are a helpful assistant. Then for the assistant role, no, for the user, assistant is the reply. User pass in the content as the prompt that you specified above. And then for the images, now for the images, you pass in it's either you pass in a byte encoded data for the image or the image path. So which are we going to use? We are going to pass the test path, the test image path. We're going to use the URL instead of the byte encoded data. Test image path, and then we print the answer. I want to see your replies on the chat. What is the question? What a better? Oh, the question is, do you think the AI will get everything correct? You see, these are the actual values, yeah? Do you think the AI will get everything correct? For me, I think it will get the parish wrong, because I struggle to find the parish. Yes. Do you think it will get the answers correctly? So we have the system, we have the user, content prompt, passing the image path, content. Nice. Now to the real. Give you a sec. Okay. No module named Olama. What? Have we not installed Olama? Okay, let's install it real quick. Pip install Olama, the SDK. Nice, it's downloading. Okay, this is the image. Yeah, and these are the values. Which values will the AI get wrong? I bet it will miss some fields. Which exactly? Okay, since the time is running out, and I want us to like test one of the images, yeah. For me, I guess it will get the parish wrong, but I'm not sure. Maybe it will surprise me. Okay, nice. Oh, we have to see the memory compute, RAM. Oh, GPU, 5 GB, 5.2 GB, and remember it's a 3 billion parameter model. It consumed 5.2 GB. 5.2 GB, 3 times 2, 6. Nearly there. Nice, and these are the answers. These are the answers, bro. Surveyed for. Okay, let's copy the correct answers. So these are the correct answers. Let's cross-check. Land Surveyor, it got the answer correct. It actually is more accurate than this because it included the middle name. And when we look at the image, actually there is an E. Jennifer E. Elaine. Bro, a 3 billion parameter model is doing this great. Certified date 2020 9/17. 2020 9/17. Surveyed for Rico R. Wilshire. Rico R. Wilshire. Bro, this is a 3 billion parameter model. Total area 596. Oh, we need to specify that this should be a float actually, a valid float to ignore the units. But it got it correctly. Unit of measurement, bro. Square meters. Address lot 468 Ruby development stage 3 part 1. Okay, it got the address wrong. It struggled. Parish, White and Harris, St. Philip. Obviously, it would have struggled here. LT number, it got this wrong. The LT number is 77.039068. So out of all the fields, it got 1, 2, 3, 4, 5. 5 out of 8 fields correctly, and it's a 3 billion parameter model. Yes. So that's how you use a visual language model to answer OCR tasks, to extract tasks from the models, etc. So this is the end of the stream today. Tomorrow we are going to continue, and tomorrow we are going to make a submission. We're going to make a submission using this model, hopefully, yeah, and fix some of these issues. Like for this, it got wrong. For this, it got wrong. Actually, for this, I promise you, I would have got. Yeah, the address is actually pretty tough. Yeah, address at how wait, let's see this address that it got wrong. It said it's 16 categories and fine. 16 categories and fine. Where is that? 16 categories and fine. 16 categories and fine. 16 categories and fine. Bro, I cannot see where that is. But I can see Saint Pine here. Saint Pine. Actually, I feel like Saint Pine should be the parish. I don't know where Saint Philip is coming from. Can you see Saint Philip here? I bet, honestly, I cannot see Saint Philip here, to be honest. Yeah. Okay. Thanks, guys, for joining the stream. I really appreciated my bro Simel and my brother Kid Nuts Napoleon. Thank you for joining the stream. I hope you enjoyed. And I hope you haven't had fun seeing a visual language model at work. See you tomorrow when we further improve this and make a submission on Zindi. Thank you, guys. Oh, I'll show you one last thing. To save your progress, it's like Git for Kaggle. Just say running the prompt successfully. Yeah, you don't need to save and run all. You only do this when you want to save files and leave it to run the whole night. Currently we don't, so we just need a quick save. Yeah, and we save it. Yeah, thank you guys for joining. I would love to hear your thoughts. How was the stream, Simol? Did you enjoy the stream? What can be improved in the stream? etc. Yeah. Yeah. I thank you, Simel. I should be the one thanking you for joining the stream. At least you motivated me while on the stream. You know, like I actually get so disappointed when I'm the only one on the stream. Yeah, like sometimes I just give up, man. Like last week I was so like disappointed. I never even wanted to like stream, but when people like you join the stream, make it amazing. I really appreciate it. It motivates me. I feel like I'm not alone. Yeah, but I know most people watch the replay, to be honest. So, yeah. Imagine you can do it. You can do it. Actually, let me download this notebook and send it to you because you are on the stream. You actually deserve it. All the others need to write the code themselves. I will send the notebook to you, like personally. Yeah, I'll send the notebook to you so that you can experiment, play with the prompts. I'm sure you know prompt engineering. It's the same thing you do on ChatGPT interface, but now programmatically. Also, you need to sign up for a Kaggle account. Make sure you phone verify your account so that you can get access to the GPUs. Signing up is very easy. It's the same way you sign up to different sites. Oh, your data listened as well. Say hi to Naila. Say hi to Naila. Tell her Uncle said hi. But anyway, thank you so much for joining the stream. I'm gonna end the stream now. See you tomorrow. Adios.